Other questions? All right, thank you. Our speaker this morning is Associate Director of the Alan Alda Center for Communicating Science at Stony Brook University. She has a BS in Natural Resources from Cornell and a PhD for Marine and Atmospheric Sciences from Stony Brook. I'm looking forward to this talk very much, and I hope we all get as much out of it as I'm expecting. So, Christine O'Connor.
No pressure. Can everybody hear me? Yes. So this is going to be a little different. It's actually going to be very interactive. It's going to be a conversation between me, you, and each other. So for those of you in the back, I'm going to make one more plea to move forward because I want you to be able to hear each other as well. So if you could just stand up the last few rows and fill in a little bit up front so you can hear each other. And also, you're going to be standing up at points, interacting. So those of you with computers, you're going to want to put them away at some point. I see lots of little apples all around the room, so if you can put them away now, that would be great. So my name is Christine O'Connell. My story is that I started out as a scientist. I started out going to school for science, and I was really passionate about environmental issues, and that's where I did my bachelor's at Cornell in Natural Resources, and this was in the 90s. And in the 90s, the internet was there, it just wasn't as big. We didn't have blogs, we didn't have lots of outlets for science communication. All the research I did just ended up in journals on a shelf in a library that nobody else looked at other than other scientists. So I got a little disillusioned by that, and I decided to leave science altogether and go into environmental policy and advocacy, which I did for about 8 years, working on national environmental campaigns, working with Congress to develop policy around environmental issues and communicating about science to policymakers. And after about 8 years of doing that, I decided there wasn't enough science in policy. So I left policy altogether to go back to science and see if I could merge the two, and that's when I went and got my doctorate in Marine and Atmospheric Sciences to try and merge the two. And at the time, I started to get involved with the Alda Center before it was even created. So this was back in 2009 when Alan Alda came up with this idea. He had done the series Scientific American Frontiers for about 20 years. Has anybody seen that before? So he is very passionate about science, and in the time of doing that, he interviewed thousands of scientists from around the world. And he found when he was talking to them one-on-one that he could get it, he could ask the right questions, he could understand what they were talking about. But the second the camera turned on, they switched into lecture mode and completely lost the audience. And he thought, how can I change this? How can I make this better? And he thought back to when he was starting out in acting, improvisation training, his basic improv training. And this is not improv. Most people think of, when they hear improv, what do you think of? Saturday Night Live or Upright Citizens Brigade or trying to be funny. This is a very pure form of improv that is about connection and connecting with your audience. And he thought, well, what would happen if I try and teach scientists this? So he got involved with Stony Brook, and this is when I was finishing up my dissertation, and I got an email saying, we're looking for volunteers, scientist volunteers, to do this thing with Alan Alda, and the idea is to try and make better communicators, and we're not quite sure how it's going to go or what it's going to be. And I thought, okay, this is what I want to do. I'm going to volunteer for this. And I remember the first day I got in, I was with 12 other scientists, and I came into this room, similar to this, and they put a mic on me, similar to this, and there were cameras around, and there was Alan Alda on stage, and I thought, what the heck did I get myself into? This is not what I signed up for. And he brought us on stage and started talking to us, and then started having us do some basic improv exercises, like throwing around an imaginary ball. And I thought to myself, okay, this is interesting, this is weird and way out of my comfort zone. What the heck does this have to do with making me a better science communicator? But I went back the next week. He worked with us for 6 weeks to see if this would make a difference. And I went back, and the next week we were transforming objects on stage and doing all this other weird stuff. And I thought, again, what the heck does this have to do with making me a better science communicator? And then the 6 weeks was up, and they had us do these before and after videos. And I still wasn't sure if I was a better science communicator after all of this. But they had us watch our before videos and then our after videos where we were all talking about our science. And the transformation for everybody was amazing. It was phenomenal. There was such a huge difference. And that's what got us a Department of Education grant to start the Alan Alda Center. Because it was just amazing seeing the difference, including in myself. And what was interesting is I thought I was a really good science communicator. It's what I had done for 8 years. I had worked in Congress, I had worked in policy, I had worked in translating scientific issues for national environmental campaigns. And I was good at it. I taught people how to do this, to write press releases, to do media conferences. And my 5 years in grad school had trained it all out of me. I was terrible again. And that was really enlightening to see the difference. So I started working with the Alda Center, and I've continued to work with them. And since 2009, we have actually developed a pretty robust graduate program at Stony Brook. We have about 9 different graduate courses, and we're creating a graduate certificate now in science communication. And we've done, we do these workshops around the country, anything from a plenary to 1 to 3 day workshops. And we've done about 70 this year already, I would say. We went from doing probably about 10 to about 70 now, which means I'm on a plane a lot. And we've trained thousands and thousands of scientists, including this summer doing a big workshop down in DC for the National Academy of Sciences and National Science Foundation, where the head of National Science Foundation went through our workshop for 2 days. So this idea of science communication and the importance of science communication is really blowing up. And people are starting to understand why it's so important. And I want to open up with that question to you. So why do you think science communication, and not just science communication, effective science communication is so important? And this is where it gets interactive, so everybody's going to have to participate. So why is this important? Yep?
Public environmental literacy is so low.
Yeah, public environmental literacy is really low. There shouldn't be such a big debate on whether climate change is happening, but there is. What else?
The public funds our research, and we have an obligation to be able to explain what they got for their money.
Yeah, funding. You have an obligation to the public. They're funding your research. You have to put it out there for them to get. Yep? Oh.
It's difficult to have access for the general public to these journals, their subscriptions.
Yes.
People that not do it.
Yeah. Even though they're put out there online now, they're not just in some random library. It's hard for the public to have access, and even if they have access, they don't understand it.
Because if we don't communicate effectively to science, a clown will impersonate us and communicate the science.
Yes, but this is a very important point. In today's day and age, where information is so accessible, if you do not communicate what you do, somebody else will do it for you. And they might not do it right. In fact, there are people who are paid purposely not to do it right. So you have to do it.
Yeah, there's a lot of jargon and technical language in science, and we have to actually get around to sort of working in our own kind of peer group and transferring that into a form that can be used by the general public.
Yes. Getting it out there, getting the general public to be able to use it even. Not just know it, to be able to use it.
I think even at the scale that we teach undergrads from not science papers.
Yes.
Part of teaching.
Yes, it's part of teaching. It's part of teaching. Really thinking about your audience and the undergraduates coming in and what their science background might be, and communicating effectively to them, getting them excited about it. I want to ask a question. Who in here, in this room, was inspired to go into science because they had a teacher, a great teacher somewhere along the way that inspired them? Look around the room right now. That's the importance right there, inspiring that next generation of scientists. Why else?
If our work doesn't lead to action, then why are we doing it?
Okay, so getting an action taken. So getting policies made, possibly, or getting people to change their behavior. Sure.
People feel helpless about climate change,
Mhm.
and they just give up. But there are things they can do.
Okay, yeah. Giving people hope that they can do something, that we actually can make a difference and change some of these big environmental problems that are going on. I saw a hand over here.
I think all of these are about the general public, but I think it's also been important among scientists because
Yes.
there are a lot of disciplines represented in this room, and it's important to be able to communicate across those disciplines.
Yes, that is huge. That is so important, especially in today's day and age where we're dealing with these scientific problems that are massive, right? you're dealing with things like climate change. It's not just going to take a climate scientist or a wetland biologist or a meteorologist to solve these issues. You're going to need to work with economists, social scientists, people across disciplines. And it's really hard to understand. I'm going to ask a very pointed question. Who walking around that poster session last night understood every poster that they went by? Anyone? So even within your own discipline, things are so specific. We talk in our own language that people in our lab or a very, very specific discipline can understand. But it's very hard to understand beyond that. And that's one of the most important reasons, I think. Why else? Get back to policy for a second.
I was going to skip policy.
Ah, okay.
Science is really fun and exciting, and people like new, fun, exciting things.
They do. People really like it. People are interested in science. There's a reason why the Discovery Channel, why Nova, why PBS has billions of viewers and makes a lot of money off of science shows. People care about it.
Look, I don't know about the US, but in Australia, most of our politicians are either lawyers or in business. They don't know anything about science, right? In fact, some of them are really quite stupid. So, especially around climate change.
Sure.
Our Prime Minister is an utter pariah when it comes to climate change. Quite embarrassing.
So how many people know how many scientists there are in either the Congress or Senate? How many? 0. 0 now. There used to be one, Rush Holt, but he got voted out. 0. I mean, that's a huge point. We have to be able to talk to policymakers. And there's a story Alan tells where he was on Capitol Hill for a climate hearing, and the scientist was talking about science and talking about their research. And one senator leans over to the other one and says, "Do you have any idea what this guy's saying?" And the other one said, "I have no clue." And that happens every day, every day. Why else? Why else in terms of policy is it so important? Or it's communicating to policymakers?
People are irrational and biased and don't form opinion on the facts and not
Sure. And so putting real science out there for people to actually get and understand is important.
I imagine that a lot of us got into our science because we love it, we want to understand it, and we want to save the world.
Yes.
And if the public doesn't understand it, there's certainly not going to be a bad way.
Sure, sure. Who has been to a family barbecue recently this summer? Who has that Aunt Rita or Uncle Bob out there that their eyes glass over the second they say, "So what have you been up to?" Right? I mean, think about that. If we can't explain to our own relatives, our own family what we do and why it's important, then how are we going to explain to the general public? How are we going to get them excited? So that's a huge thing we hear all the time. I just want to be able to explain to my family what I do on Thanksgiving and get them excited about it. What about funding? Does anybody know who sets the NSF budget every year? Congress, yes. Congress. Does anybody know what committee? It's the House Science and Technology Committee. It's part of Commerce. The guy that runs it.
Lamar Smith.
Yes.
Creationist.
Yes. 70% of that committee actually does not believe that evolution should be taught in public schools. And that is the committee that decides how much funding NSF gets every year in their budget. What do you think happens to the NSF budget every year? It goes down. So this is why it's crucial for scientists to be able to communicate what we do. Because politicians need to see that it's important. If they don't see the importance of basic research, they don't see the importance of funding climate change research or some of these other things, they're not going to. And who do politicians listen to, in theory?
Voters.
Who are they supposed to listen to? The public, right? If the public doesn't understand why we should be funding fruit fly research, then they're going to say, that's silly, why are we spending $1 million on this? But we're spending $1 million on it because it can help us understand the genome, the human genome, and lots of public health issues around it. But if they don't understand that, they're going to say, don't fund that. They're not going to be writing to Congress to say we should put more money into science. They're not even going to understand that science is being cut. So this is a huge issue. But I want to get back to something somebody said before, and this is why I think it's most important. So communication is not something you add on to science. It is the essence of science. And this, for me as a scientist, is one of the most important parts. What is the last step in the scientific method? I heard publication. What is it? It's actually not publication. What is the last step? Communication is the last step in the scientific method. A lot of us take that as publication. Publishing in a peer-reviewed journal or giving a poster at a conference, but it's actually communication. And I'd like to put out there that communication actually doesn't happen until the person you're talking to or trying to communicate with gets what you're saying. Otherwise, you're just talking. So it's up to us to do better, to actually communicate, to make it so people get what we're saying. Because you know what? If we're not putting our science out there for other scientists to get, for the public to get, to policymakers to get, it's not building. And for me, that's what I love about science. It's this living, breathing thing. We're supposed to be learning from each other, taking things from each other and building on it, and learning more and then building on that. And it's growing. If we can't understand what everybody else is doing in the room, how can we do that? How can we get inspired? You can't understand every single poster that you walk by in that poster session. How are you learning from it? How are you learning about the way you look at your own research? And that's why it's important to me. So we're going to shift gears for a second and talk about baseball. Does anybody know who this is? Derek Jeter. Does anybody not know who this is? Good. Who here knows nothing about baseball? Doesn't know the rules? Has never seen a game? Keep your hands up if you know absolutely nothing. Oh, good. All right. What's your name?
Steve, I'm Australian.
Steve, Australian. And what's your name? What is it?
I can explain cricket.
Ilium. All right. So, those of you who understand baseball, I'm going to show an abstract from the sports pages in a second. This is an abstract from a game. So the reason we do this, the sports pages are the part of the newspaper that actually requires the highest level of knowledge going in to understand than any other section of the newspaper. And it's written for that, just like a science journal is written for scientists in your discipline. So it's written for that audience. You know the backstory, you know everything. So I'm going to put this up. So those of you who understand sports, you're going to understand what this is about. Those of you who don't understand baseball at all, what does this mean to you? So, who gets this? All right. Your job right now is to explain to, what is your name again? Steve. What's going on here? Who wants to take a crack at it?
The Red Sox won very fast.
Do you know what the Red Sox are? Oh, all right. You do know a little bit then. But for someone who knew nothing, they wouldn't even know that that's a team. And this is where you have to think about your audience. Your audience knows nothing about baseball. So this is exciting to you, right? Somebody who wants to give this a try and explain it. All right, come on down. It's up.
Okay. That was the ninth inning. The last inning of the game. There are nine tries at bat. Each team gets 9 tries. Each team gets 3 outs. 3 Now, you didn't tell me I was going to have to explain the rules. I can explain what that means.
audience? Are they going to understand the words you're using?
It was the end of the game. It was the end of the game of baseball. Derek Jeter, who's a superstar player, he came up to bat.
Mm-hmm.
And
What does it mean to bat?
the other team throws the ball close to him, and that's how the big stick. If he can hit the ball with the stick, I mean that's his objective. He wants to hit the ball with the stick, and he wants to be able to then run to a base, to a station. And he wants to run to first station.
All right, I'm going to stop you here. Good job. That was a good try. It's really hard to do. Does that make you interested in baseball?
Yeah.
Whether you're interested, be honest.
I didn't realize you got paid so much money just to get a stick in the ball.
So it's really hard to do, right? Who can try and do this again? And get them objectives to get them excited. If you read this and you're a sports fan, you're excited about this, right? Get them excited about it. It's right here.
Two professional teams, the New York Yankees and the Boston Red Sox, were playing America's oldest and hottest sport, called baseball. It was very near the end of the game, and the game was close enough that it could have gone either way. And the great star that everyone loves had a chance to score and work some magic that got things even more interesting, raised the hopes of fans, and made the Boston Red Sox fans nervous. The Red Sox got their ace star too. It was star against star. And the Red Sox star squelched Yankees' hopes, and they all went home and had pizza.
All right. Did that make you excited about baseball more? Yes. Why? Why was that more exciting? And what tension? There was a story there, right? And you didn't have to know anything about baseball to be interested in that. Because it's a universal story. A hero going up against another hero. They're fighting it out. We're not sure who's going to win, and then somebody wins at the last minute. That's exciting. I mean, that's the storyline of most novels, right? There's a reason it's a universal story. If you can tap into those, you're going to get people excited. And the one thing somebody didn't mention, and again, this is where the bat story comes in too. Why is this even more exciting? Why Yankees and Red Sox? Yes, it's the biggest rivalry in baseball. And that idea of rivalry, again, it hits at those universal stories that people are interested in. This is something that somebody did at another workshop that is very, very similar. Take a look at it. And the idea here is this could be about anything, right? This doesn't have to be about baseball. This could be about cricket. This could be about any sport. And this is where knowing your audience is important, because you can think about what might be relevant to them. And the idea is you get somebody excited first, and then you can layer in the details. Somebody might say, well, what does it mean he took a big risk? The big risk was stealing second, right? And then you can get into the rules of the game a bit. But if you start off with the details, if you start off with the jargon, and you start off with the details, you lose someone. You lose people. And they're not going to be paying attention. So you have to get them excited first. You have to get them engaged first. And then you can layer in the complexity. And you know what? If you get a question, you've done your job. You've engaged them. So we're going to try this with science. But first, I'm going to hit on this a few times throughout the presentation. Two things I want you to come out of this presentation with is know your audience. Always know your audience and always know what your goal is. I'm going to give you an audience before I give you a scientific abstract that we're going to try and distill for this audience. So this is your audience. We went around Stony Brook and asked everyday people questions about science. The sound will come on in a second.
What is basic research?
I know different types of research. Experimental, correlational, descriptive.
I guess it's the science of discovering what things are about.
Basic research, I think, is just scientific method.
Research, like on basic items, basic information. I mean, I really don't know.
Basic research, I'm specific to what, I'm not really sure.
Can you give me one example of what basic research would be used for?
I mean, it could be like medication, anything really. Something simple and not complex.
Space travel.
So the work that they're doing at NASA would be considered basic research?
Yes, for the future.
What is global warming?
Well, I don't know if it has to do with the tipping of the Earth or something coming near us that things are changing a little bit.
Global warming is the thing that everybody talks about. Global warming.
Global warming. Global warming is just a year.
I think it is like what we're just doing, we're destroying. And I don't think we really know what we're doing that's destroying, so I think we just keep destroying.
So do you think global warming is real?
Yes, very much.
You know, I'm not sure. I mean, it looks like it is, but I just don't know enough.
I think it is. I think what else going on is real. You know, I just think that we just keep ignoring it.
They say, you know, global warming is bad, but they never actually say, like, exactly, hello, this is global warming.
What is DNA?
That's what the human infrastructure is.
It's what we're made up of. Humans are made up of a certain genetic makeup.
Something to do with genetics.
Where is DNA located?
In your hair.
I cannot say that. I don't know. No clue. Sounds like space.
Micro technology going into like clothing. You know, stuff like that. Does that help that field? Because now your socks smell better.
Really something small.
Super small.
So yeah, I'll go super small, sure. Super small, super duper small maybe. Communications, electronic stuff like that. I don't know that because of the iPod Nano. That's how I know this.
Okay. Who was surprised by that? What did he do at the end there? He didn't know what nanotechnology was, but what did he do? Yeah, he tried to find that association. And people do that. People want to know what you're talking about. If you say a word they don't understand, they're going to go through that old card catalog in their brain to try and find something that has to do with it and make an association with it, like the iPod Nano. But the problem with this is, what are they doing? What are they not doing as they're doing that? They're not listening anymore, exactly. You've lost them already. They're not paying attention. So this is why jargon is really bad, because you lose people automatically. They're going to want to know what that word is they don't understand. Sometimes they're going to be right, sometimes they're going to be wrong. We ask people, we do a lot of medical work too. We went around and asked people what metastasis was, and if that was bad in terms of cancer. And a lot of people came back and said, well, there's static in there, so it probably means it's not moving, so that's a good thing. When you say cancer has metastasized. Now, we know that that's a bad thing. It means it's spreading throughout your body. So the associations people make might not be right. And that's your job. That's your job to think about that. If you can actually think about the associations people are going to make when you talk about a concept or a certain word, and make those for them already, you're going to engage them more. And that's really thinking about your words, thinking about what the words you're using and what those associations might be, and creating a visual for people. And we'll talk about these things as we go. So I picked an abstract that I thought everybody here could understand. So I want you to read this abstract. This is from 2002 in Science. Take a look at it. So this was written in Science, which is supposed to be broader to begin with. How would you take this? How would you describe it to those people, to that audience? Yep.
Fishermen like to catch big fish.
Uh-huh.
But when we do that, there are little fish that survive and they have babies, and they tend to have littler and littler fish.
Okay.
If we want to keep catching big fish, we have to plan for that and make sure we don't catch all the biggest fish out there.
Okay. So that gets at it a bit. What else? Who else can add to that?
The people who run the fisheries are not paying attention at how to optimize better their yield. A way to do so is by looking at the new fish and remove those that will not contribute to the better productivity of your fishing.
Okay, do you think those people are going to understand what optimized yield is or better productivity of your fishery? So think about that. How would you talk to that audience?
Okay, if creationism was true, we'd have plenty of big fish out there.
You might alienate people that way, though. You don't want to alienate them. You want to get them excited about this, but you want to get to the point of it.
If the space alien came to Earth, they killed all the biggest adults. And only the smaller adults could keep making babies. And only those babies could keep making babies. Because anytime a baby got to be a big adult, the space aliens would kill them off. After 100,000 years, or 100, or 8,000, or 50, or 20 years, people on Earth would be smaller than they had to be before the space aliens came.
Okay. But that's a good try because, you know what? It's a reality that people care about people. And anytime you can personify something and give an example that has to do with people, they pay attention. What else?
The recommended plans that we're using to harvest fish are lowering their quality and the quality and the quantity we're able to.
Okay. That's good. How could you say that more? Get at the excitement there. Because that's a big deal.
You can use this information to better preserve the big fish that are out there that you want. It will help plan for what you want.
Okay.
This is one of the most important foods for us, and so doing so is reducing our important food supply.
Okay. So getting at the point that it's an important food supply. We're taking out the big ones and only little ones are left.
Let's say if you're going to have a barbecue with your family, you want to have a big fish, and right now what we're doing is we're just eating the little fish, and then you won't be able to feed your family when they have big barbecues.
Okay. Okay. But getting to that, saying that, being personal, it gets people interested in it because people care about other people, again, and they're going to care about you if they know a little bit about you and you bring that into it. Sure. Why not? And again, try and do the whole thing. Get at what this whole abstract is. You don't want to leave the point of the abstract out.
Fish is one of the most important proteins for people who are hungry on this planet. And the availability of fish also has some wildlife repercussions. When people can't get fish, they will hunt and kill monkeys and other things.
No, but that's a good, you're getting at it. What? Somebody else try it.
I'd like to eat like tuna or something versus having schmelz. Can you imagine having to eat schmelz? If we don't take into account that we're kind of just leaving the small-sized fish, I'm not going to have my nice tuna steak. And I want my nice tuna steak.
Okay, so getting at to the person you're talking to, making it relevant to them. They might eat fish. They might like tuna. Sure. But what's the point of the abstract?
So you've probably heard about survival of the fittest, and that's usually how nature works. But fishermen have turned that on its head, and now we have survival of the weakest, and that's leading to weaker and weaker fish populations, which will affect harvest and affect the whole ecosystem of the ocean.
Okay. So you're getting at the point there. So what did they find? What did they find? You don't want to leave out what they found. You don't want to simplify it too much where you actually leave out the science.
So, big fish are really important for food supply on the planet. They are the main source of protein for lots of the Earth's population. Fisheries managers have, for a long time, gone about their management plans in ways that basically allow people to catch the most fish they can. Our science has shown that when we take the big fish and we leave behind the small fish, the population gets smaller and smaller over time. So we need the fisheries managers and the scientists to understand this new information so we can do better management to retain big fish populations.
Okay. Is anything missing from that? What else is missing? Huh? Okay, what's missing? Somebody try.
One of the things that seems to be missing is, going back to Jonathan's, is that there are differences among fish. And we can't treat every fish as the same fish. So we have to manage as if there are differences in fish, just like there are differences in people.
Okay. So maybe working that in a little bit?
So I'm assuming this is, we're talking about the same species of fish. The one that grows faster get caught and eaten. The one grows slower just got saved. So that means now if we want to eat a big fish, we have to wait 10 years instead of 2 days.
Okay. Is that what's going on here? All right. Who thinks they can take this and describe it? The whole thing. Out of all that, take the best things that were said here and describe it. Get to the point. Get to the science here. All right. Come on down. Wait. Hold that thought. Hold that thought. Can you come down?
Come down?
Come down here. So we actually have some non-scientists for you to explain it to.
Who are they?
We're going to get them now. They're coming in.
Why did
No, nobody's going to raise their hand. You guys are going to help him, okay?
I need a lot of help. Are these going to be big guys with chains?
They're going to hit you every time you've done something wrong.
One hero against another. Goliath versus.
Okay.
I know that guy. He's a scientist.
All right. Come on in. I want to thank our volunteers. You can come up here. Hold on, I want them to introduce themselves. So if you want to give us your name and what you do.
I'm Susan Rula, Society Sport Manager for Schneider Group, and we do the conference management here.
My name is Jennifer McConaughey. I also work with the same company as Sue, and I am the Assistant Project Manager.
My name is Leanne Alba. I work at the University of Mexico as a web designer for the physics department. I'm a volunteer.
Thank you. All right. So if you want to turn around and take a look, don't worry, you don't have to understand this. This is written for a scientific audience, this abstract, and they've been talking about how to describe it and get people excited about it. So he's going to, and what is your name again?
Newt.
Newt is going to describe to you what this is all about, and I want you to just listen. Okay?
Okay, so you didn't know the.
Oh, you know, stay up here.
Stay here. I won't embarrass you. I'm as embarrassed as you are. You guys are very brave. So, do any of you fish? No. Never fish? Kind of fish?
I eat fish.
You eat fish? Well, when you kind of fish, do you watch out for game wardens?
Oh, yeah.
So why don't you watch out for game wardens?
Our license.
License, and what? And if you're what kind of fish do you fish?
I just kind of fish to fish. I don't have a particular fish.
Okay, but you have to pay attention if the game warden's around to making sure that the fish you catch is big enough, right? Because what we've done ever since we've been regulating fishing, is we set size limits. And we really, and the way we think, and I grew up fishing, the way we think about fishing is throw the little ones back so they can get big. And keep the big ones because they're easy to clean and easier to cook. And plus, the game warden is okay with that. Well, what these people have discovered, amazingly enough, is that's the wrong strategy. We shouldn't be just keeping the big ones, because there are all kinds of fish, even within the same kind of fish. Let's say you're fishing for trout or bass. They're not all the same. And some of them reproduce, they grow to a certain size and then they lay eggs, and others, there's enough variation in the fish that some fish grow large and others, just like I'm taller than you. Doesn't mean that you reproduce any less. We're going to favor the ones that reproduce at a smaller size. And so we've got to really rethink our fisheries. Because fish change, people change. I mean, if you look at pictures of people from a century ago, they're generally smaller and thinner. That's not really evolution. So these scientists have really discovered something interesting. It's contrary to what we think normally. Let the little ones grow, keep the big ones. That's not what we should be doing. If we want to keep fishing in motion for decades and centuries, so people keep eating. Does this really make sense to you, or should I explain it? Yeah. So let's keep some of the big ones, but let's eat more herring. Instead of well, that's a different species. But if you're from Norway or Denmark or Germany or your ethnic background is a herring background, keep eating those little big herring, and let the big fish have their place in the ocean.
All right. Good job. All right. Stay here for a sec. Wait. We're not done with you yet. Come back. So, do you have any questions? Did that interest you? Do you have any questions that come out of that?
It was interesting to me.
Why? What was interesting?
Well, it was new information. I don't fish, but I appreciate the sport, and I do like to eat fish. And just the newest technology and science, and it makes common sense.
Okay.
It was definitely informative just because, on my perspective, I do have to think about the game warden. So with that, that's definitely interesting because I don't think like that. Like, that's not my perspective. So that was definitely very informative.
I think what I liked about this is that you first asked us, what do we know about fishing? And what's our perspective on fish? Personally, I would like to know, do you have some good recipes for smallmouth?
All right. So, my other question to you is, if you leave here today, you're having dinner tonight and saying, I learned this really interesting thing, what would it be from this? What would you pull from what he said? What would you remember about it? What do you think the point of this was for you, from what he said?
Let's eat little fish rather than big fish.
Okay, so that's what, all right.
In terms of size of the
Okay. Is that what this was getting at? No. All right.
My interpretation was.
But that's yeah, exactly. And that's what I want to hold on to for a second.
My interpretation was we need to have a variation in what type of fish that we catch, the big fish and the little fish, and spread it out a little bit.
Okay.
To me, in my mind, I just sum it up as genetics.
Okay. All right. So, can anybody else try and get to? You can sit. You did a great job. Thank you. But the point of it is, you can actually see how somebody would take the wrong meaning from what he said, and this is what you really have to think about. What's your goal? What's the point here? I see somebody raising their hand. Do you want to come down and try it? And this is why it's important to actually try it out and ask people. There you go.
Okay, this story about Mark. You would like to go shopping? What happened with your prices in the market changed when in the store you used to go changes in and you didn't know about that before? Do you like to plan your budget before going to the store and oh, this is how much I want to spend in something, and then you go there and it's they rise the prices and you can buy that. How do you feel about that? Frustrated or right? It happened to me. I'm a graduate student and I'm limited amount of money, so all the time, right? So it turns out that nature has its own market rules. We as scientists call it evolution. But those market rules, change the prices of things in nature. But sometimes people ignore those rules and ignore the prices, so they try to go shopping and they can't find the stuff. So that's what people is finding, or this is what I recommend here. Pay attention to the changes of the prices, because otherwise you are not going to find the fishes you need for the people that care about it.
Okay. What did you think about that?
I think it's a very good analogy, and it makes very good comparison to a non-scientific, everyday process.
Do you feel like you understand the abstract, though?
Maybe it was a little bit too abstract.
Okay. And this is important. You want to give analogies, and it was a great start, but you don't want to lose what's important. You don't want to lose communicating about the science and what they actually found.
I have to agree with Sue on that as well. That's kind of how I felt.
Okay.
It's not exactly to the point, but definitely a good analogy.
I don't think that what you had said had to do with what was up there as far as I because I have to unpack it. It's like a poem. I have to really look at each thing and see what it's trying to say. I don't think that what you said was really what that means. But maybe it did for you, Ryan.
But that was a good shot, a really good shot. And coming up with an analogy and building on it. Who wants to build on that? Good try. Nice job. Come on. And don't look at this and try and translate word for word. Just listen to what forget about this. But that was great. Coming up with an analogy and building on it. And coming back to the science.
Well, hello. I appreciate very much the work that you've been doing with the Snyder Group over the years and great meetings. I'm a Toastmasters person, so it's happened biased. I love her inputs. He always deconstruct absolutely everything we do and tears to pieces. So I want to tell you a little story about what the scientists have been discovering about how we do and run the fisheries. We know that we need to eat fish and we have a lot of people. We want to make them better. However, we think that we are not doing a great job in managing those fisheries. So they discovered, the scientists, that using genetics, you know about genetics, a little bit? You've heard that, like the word, right? So using genetics, they found methods to make more fish and more productive, and they reproduce faster. So we can address a problem that we have worldwide, that is supplying fish for everybody needs. That's it.
Okay. Do you have any questions on that? No? Okay. Do you have any?
I guess I would like to have more. I mean, that was a good start. In a short amount of time, it's good to be briefer rather than more talking longer, right? But I mean, okay, so you're saying that you have fisheries, people are trying to manage them, and they're using genetics to adapt the fish, and then what?
No, I kind of like, almost, I tried to say that, but no, I didn't try to say that. I tried to say that the people who manage the fisheries, and actually they want to fill their pockets with money. That's another goal that they have, not just save the planet and by providing a lot of fish, but that they found that they use some science studies that rely on genetics to come up with methods or plans to actually have more productive fisheries. That's what I tried to say, right? I don't think I did a good job, so I'm sorry.
No. That was a good start, and it's bringing it all together. Who thinks they can actually tell them why we should not keep the big fish? Oh, okay. We have someone running down. This is exciting. I feel like the price is right now.
Hi, my name is Ruth. What's your favorite vegetable?
Carrots.
All right, do any of them grow like in nature the way you want to eat them?
No.
So how are they developed?
People took the ones that were pretty good and they just kept taking the seeds.
Yeah. Yeah. It's called artificial selection. So, this cool thing these people found is that we can do the opposite with fish in the ocean. Because when we eat the best ones, what's left? Worst ones.
Dumber ones.
Slower growing ones, because we take the biggest ones. So what are we going to end up with? We get better and better spinach and carrots and asparagus, but our fish can get worse and worse.
Okay. What do you think of that? Okay. Yeah?
Yes, it made a lot of sense, and again, to a non-scientific, everyday comparison, and very succinct.
Okay.
And a lot of knowledge in a little bit of time.
Do you have any questions? So out of all the things you've heard, do you have any questions or things you still don't understand? And don't worry about looking at that. Are there questions of, do you think you have the big picture now?
I guess I'm wondering about policy. I mean, if there are fish in the ocean that we're not growing them or feeding them, catching them, using them efficiently, how can we do it better?
Okay. Okay, so understanding, wanting to know more about the policy. Has any of this interested you? Do you think you'll go back and say, I learned something really interesting today? So what's the most interesting part out of everything you've heard?
I would have to say Ruth explained it very well, and it really interests me as to why we're so selective. Like, what can we do to expand, to not be so selective, so we have a broader genetic pool of fish?
Okay.
Pretty much what has been said already. I've been interested personally in the evolutionary process, and not having time just because of the busyness of life. It's just nice to be like, okay, this is a quick synopsis.
Right.
Okay, thanks.
Okay. All right. So, thanks. I'm gonna bring up something that we put together in another workshop, and I want you to read it, and I want everybody here to read it to see if this brings it all together. Because I still think we're missing the biggest piece, which is why the big fish. Why is it important?
It's an important food source.
It's an important food source. Why else?
Big fish make more big fish.
Yes! Big fish make more big fish. What else? Why else?
More big fish though?
More fish. Big fish make more fish. As fish grow, the bigger fish lay more eggs. I think somebody mentioned that a little bit at the beginning, but it got lost. So big fish are important because they make more fish, and they're bigger. And they're usually stronger and more robust. So those are the kind of details you want to make sure you put in there. All right, I'm going to show this explanation and take a look at it. It doesn't quite fit. It's not a perfect explanation, but does this make you interested in it more? And have more questions? Does this fill in any of the blanks from what you didn't get before? Or do you think you got most of this? Something?
pretty much gone.
Yeah. I mean, are you saying that this is what is the dumb person's explanation for
It's not. This is just like a layperson's explanation. And this, I'm glad you said that, because it's not about dumb. And I hate the phrase dumbing it down. And I hear a lot of scientists use that phrase, I don't want to dumb down my research. It's not about dumbing it down. It's about interpreting it to another audience. If you talk to someone in business, if you talk to someone in event planning, you're not going to understand the things that they know about either. Because if they talked in their lingo.
Yeah, but we're really dumb.
No, and the idea is it's about interpreting. And you can't go line by line and interpret an abstract. You actually have to get to the meaning of it. What is the so what here? Why do people care? And there's no right or wrong explanation. It's just really working with your audience to get there.
So I just see one missed message here, okay? And that is that somebody could say, well, gee, maybe instead of eating tuna, we should eat herring. Because a tuna is big and a herring is small. So it doesn't say anything about
The same species. Right. And that's a good point. And it is an important message that it's the same species of fish that we're talking about. Yes. Yeah.
So I think there's 2 points that should be added.
Mm-hmm.
2 points that should be added to this. So you as a consumer fish, that probably, if you didn't take this management role into account, that would probably mean the large fish that you like to eat won't be offered so often in this restaurants. That will probably cost more. But imagine you do that just because you like to eat fish. You have alternatives. Unfortunately, most of the world depends upon fish for food. And not only they will have to eat smaller fish, there won't be enough fish to feed them. So they won't not have to eat fish when they go to the restaurant. They'll starve.
Okay. Does knowing that make it more interesting to you? Yeah. So that's the thing, getting to these pieces that make it more interesting. Filling in the holes, just like filling in the holes that the Red Sox and Yankees are the biggest rivalry out there. You know that going into it. You know the backstory of this. You know why this is important. Somebody just coming in and reading it doesn't know that. They don't have that. So it's up to you to fill in the backstory, to fill in the so what. And I want to thank you so much. That was really helpful. Thank you to everyone who tried it out. And it's not easy, and there's no one right answer, but it's really getting to the so what. If you get to the so what, you give them the meaning of it, people are going to pay attention, and then you can fill in the details. But you have to get to the point. And anytime you can say to someone, well, we thought it was this way, but it's actually this way, we were wrong. That's inherently interesting to people. People pay attention to that. There's a reason why reality TV out there is so popular. People like conflict. And if you could talk about that, people are going to be interested and relate it to their lives. So I like this diagram. I think it really gets to the point of it. This was published in Physics Today. And the green triangle is the way we as scientists think. And the red triangle is the way the public really gets their information. So let's focus on the green for a second. If you think about a scientific paper, even an abstract, we give the background first, then we talk about our methods and results, and then at the very, very end is where we get to the conclusion, is where we get to the so what. And I challenge you, most abstracts are actually written this way. The last sentence of the abstract is going to be your so what. And a lot of journals are actually changing this. Science Now, Nature Now, actually makes you use that triangle. They make you flip it. Because they realize that even we as scientists like to get our information that way. And I want to throw this question out there. What is usually the first thing you read when you decide you're going to invest and read a scientific paper? What's the first thing you read? The title. What's the second thing you read? Abstract. What's the third thing? Figures. What else? Conclusion. And then you decide you're going to read the rest of it, right? Admit it. We've all done it. We've read the title, we've read the abstract, we go to the discussion to say, okay, we're going to invest in reading the rest of this. Even we like to think that way. When you decide what you're going to read in the morning, your newspaper, what articles you're going to read, most people, they go to the title, then they go to the figures, and then the first sentence, and then they decide whether they're going to read the article. So we have to flip that. We have to give the so what, the bottom line. Why is this important? Don't make it hidden in there. Don't leave it for the last thing you're going to say, because you know what? You might have lost someone already by that point. Get to the point right away. And always give the so what. The so what here is that this is a huge food source for a lot of people. And if we want to keep having fish to eat ourselves, to eat for other people that depend on it, we need to change the way we manage them. That's the so what. And if you don't give someone the so what right away, what are they going to be thinking the whole time you're talking? What's the so what? Why do I care about this? What does this mean to me? They're going to be thinking about that the entire time. And if they're thinking about it, again, what are they not doing? Exactly. So you have to address it. It's the way people think. You have to get there. So we do this at the Alda Center. We have two methods that we based a lot of our things on. I talked about improv a little bit and this idea of distilling your message. Getting to the point of what you're saying, using clear everyday language, and making it engaging for people. And improv is all about that too. It's making a connection to someone. And we're going to do an improv exercise in a second, but I'm going to show you a before and after video for someone for the iBiology contest. Does anybody know iBiology in here? So we coached the winners of this contest, and we did before videos before we coached them. Then they got a 3-hour improv session and a little distilling coaching. And this is a before and after.
Gradient tracking is the process of orienting polarity of an extracellular chemical gradient. And lots of different types of cells can do this. One of them, I'm going to show you a video here, is dictyostelium. It's an amoeba. And it's attracted to the chemical cyclic AMP. And in this movie, there's a pipette, which is out of focus. And the cell is attracted to the cyclic AMP, which is being released from that pipette. So the cyclic AMP is at the highest concentration at the tip of the pipette. And the cell orients itself with respect to the gradient so that it's going up the gradient and trying to get to the highest concentration of chemical.
Imagine that you walk into a friend's house, and in that house they're baking cookies. But you've never been in this house before, so you don't know where the kitchen is. So how are you going to find these cookies that smell so delicious? You're probably going to sniff, and sniff, and then you're going to go in the direction where there are the most number of, where there's the most smell of cookies. So that smell is actually molecules that are being released by the cookies. And the most number of those molecules are in the oven where the cookies are baking. And then they're diffusing away so that there are fewer and fewer molecules the farther and farther away you get. So when you walk in the living room, you can smell the cookies, but it's still kind of a light smell. And as you get closer and closer to the kitchen, as you go, I'm going towards the cookies, as you go up gradient, when there's more and more of that chemical, the stronger and stronger that scent is. So that's actually exactly what sperm and white blood cells do, is there's a chemical that's being released by either the eggs or the bacteria, and those cells are able to smell, they're able to detect that chemical and go up the gradient in order to find their target.
So what did you think about the difference? See the power of it having an analogy and then bringing it back around again. You have to bring it back around to the concept. And using terms, she used jargon in there, but she described it first. And you have to describe it first and say, that's a gradient, that's gradient tracking. That's exactly what's going on here. So I want to try, we're going to try an improv exercise right now. And this is where I'm going to make everybody stand up and find a partner. So look to the person next to you, stand up in your seats. You can spread out a little bit. Feel free to even come down here if you want. Find a partner. If you don't have a partner, raise your hand. Oh, there's 2 people. Raise your hand if you don't have a partner and find someone. There. Oh. Here, wait. I have someone for you right over here. Oh, wait. Who doesn't have a partner? Oh, one up there. Come down here. We have some. Oh. All right. All right, everybody found a partner. What you're going to do is face your partner. Try and put your arms out, tip to tip, and take a step back. All right, this is where we're going to spread out a bit. I told you have to put your computers away. Okay, put your arms down. We're going to play a game called Mirror. You are going to decide right now between you who is person A and who is person B. All right. Person A is looking into the mirror. Person B is their reflection in the mirror. So person A is going to move, and person B has to do whatever they do and move with them and try and follow them. Okay? I'm going to give you a few seconds to try this, and then we'll come back to it. Go. For a second. All right. I want everybody to pay attention up here. All right. Now, don't tell us who's person A, who's person B, and go. Who's leading? Yes, you're leading? How can you tell? Huh? She's ahead. Okay, so think about that. You're supposed to be a mirror. That's your assignment, right? In the mirror, when you raise your hand in the morning, does it take a second to get there? It would be a little freaky if it did. I'd be scared. So, what can you do differently? What can she do differently to make it easier? What is your name? Christy and Krista. Oh, wow. And I'm Christine. All right. That's not planned. All right, what can Christy do differently so that Krista can get it? What can she do? Slow down. Slow down. What else?
Tell her ahead.
Tell her you can't talk. You can't talk. Huh?
Exaggerate.
Patterns, okay, sure. Do patterns. I heard you say something. Eye contact. Your focus should not be on what you're doing next. And this is huge. Your focus should not be on what's coming out of your mouth next, what you're about to say next. Your focus should be solely on her and whether she's getting it or not. And if she's not getting it, you have to change something about what you're doing. So you should your eye contact should be completely on her. And I know it's weird to look somebody else in the eye, but we're going to practice this. But your focus should be totally on the other person, not on doing something crazy and thinking about what you're going to do next. It's are they getting it, and what can I do differently to change that? This is important, and this gets back to the point of communication. If somebody's not getting it, you're not communicating, and that's your fault. That's your fault. It's not their fault, because they're trying. For the most part, people are trying. They want to understand it. You're not doing something right. So what do you change about what you're doing to help them get it? So going slower was one. What else can we do? Simpler movement. Not about trying to be funny and do jumping jacks and do crazy things, right? That's not the point here. And this is where goal is important. Your goal is to get them to be the exact mirror of you. Don't forget your goal. Repetition, sure. It could be another thing you do so they can kind of think about what you're going to get. And think about that. This all works with talking, with talks.
Are there any surprises?
Surprise movements, yeah. So try and just be simpler. So let's try it again. Think about being slower, simpler movements, eye contact completely with her, and your focus should be completely on her. Nope, we're going to watch for a second. There's no race here, so even slower. Better? All right. You're all going to try that now. So get with your partner. I don't want anyone to be able... Good job. That was great. Did you feel the difference? Your focus was on her. And you'll see it. The second your focus goes into your own head, shoot, what am I doing next? How do I look? When you start questioning yourself, you're your own worst enemy. That's when you totally lose the person in front of you. And that's what improv really helps with. It helps shift the focus. So if you get nervous before giving a talk, it really helps with stage fright because you're putting the focus on your audience. It's not about you anymore. It's not about how you look, how you're sounding. It's about are they getting it? And it's just that subtle shift, learning how to make that subtle shift through these exercises that makes a difference in how you present. So let's try it again. I don't want to be able to tell who's person A and who's person B. I don't want to know who's leading. All right? And I'm going to tell you to switch on and off. So person B starts this time. And remember, if they're not with you, what can you do differently? Slow down. There's no race here. Simplify your movements. Eye contact. Don't look off to the side. Your eye contact should be completely on the other person. I shouldn't be able to tell. And I'm going to walk around the room, and if I can tell, I'm going to tap you out. And then you're going to be judges and tap other people out. And once you've been tapped out, you're a judge. All right, switch. Person A to lead now. Person A lead now. Remember, there's no race here. Keep eye contact. Person B lead. Time. It's going to be really sore and it's going to be hard to do, but after a while it's just so easy. And you put your focus on the other person, and that's what improv is all about. All those exercises, all the games are designed around doing that, to learn how to get the focus off of yourself and on the other person, and it's hard to do. But remember that next time you're communicating. Think about those things. Keep eye contact. Are they following you? That should be what you're thinking at all times. Are they getting it? Are they following me? And if they're not, what do I do differently? Because it's your responsibility to change that. And then this idea of distilling your message. It's talking about things in a clear, everyday way, using examples, using metaphors, so that you engage your audience. And it's based on two things that I said before. And I come back to it. This is where repetition is important. Know your audience and know your goal. Goal is important. Goal is really important. What are some goals in communication that you might have?
Change someone's mind.
Okay, change someone's mind. Get someone to think something differently. Yes, that's a huge one.
Try and explain a complex process or phenomenon in a way that they can understand.
Okay, so get someone to understand something, which is very different than getting someone to think something or to feel something.
Connect.
Huh? What was it? Cooperation, sure. Connect. To get money. Yes, to get money. That can be a huge thing, especially with funding getting cut in Congress. Your goal in communication might be to go to a private foundation or a private funder and get money. That's a huge one. And again, it's very different than getting someone to know something. So this is why you have to know your goal. Getting someone to think something, getting someone to feel something, getting someone to know something, getting someone to do something are all different types of goals, and you have to approach it differently. And then there's the idea of having an appropriate goal. And this is important. I'm not saying it happened here, but who has been to a scientific meeting before where somebody's tried to squeeze an hour-long presentation into 15 minutes? What do you get out of that? Nothing, right? And this is really important to think about. If you put too much information in something, somebody's not going to get anything out of it. Putting more is not always better. You know, you have all this work that you've done and you want everybody to know it. You know what? If you try and put too much in, they're not going to get it. They're not going to remember a thing from that presentation. And I want you to think about this. Think about the presentations you've seen this week, the best ones. How many things do you actually remember from them? 1 or 2 things. Yes, and that's why you come back to it. I'm not making it hidden. What I want you to get out of it is right there. You're going to remember 1 or 2 things. That's it. So know what your goal is. Know what those 1 or 2 things you want someone to walk away remembering tonight, tomorrow, a week from now, a year from now, and hammer those home. Design your presentation, your poster, your communication, whether it's a one-on-one communication with a funder, around that. I mean, your goal could be to get a job, to be to get a postdoc, but know that that's your goal, and know you have to structure how you're talking around that. And then know your audience. This is important. We talked about this. We talked about some ways of getting to know your audience. In the beginning, you asked some questions to the audience to try and get to see where they were. So there's knowing your audience. There's also knowing your audience in the moment. And that's where improv comes in. Are they following me? Do they get it? What are some other things I can do? You can ask a question. You can throw in a surprising fact. You can have a story. You can get to a talk early and actually talk to people and see what their backgrounds are. We're going to try one more exercise now. Stand up and find a partner again. You don't need a lot of space for this one. It could be the same partner. All right. Decide who's person A and person B. Who doesn't have a partner? Raise your hand. Who doesn't have a partner? We have somebody without a partner down here. All right, perfect. All right. Person A is going to go first. Then person B is going to go. Person A is going to talk for a minute. And person B is just going to listen. I don't want you to say anything, just listen. And then we're going to switch. The rules are, though, person A is called I am. So, for example, you would say, I am Christine. I am a scientist. I am a communicator. I'm a sister. I'm a dog lover. I'm a terrible cook. It could be positive or negative, but it has to start with I am and all the things that you are. Ready? Go. For a minute. Look around the room. Why? Why? It's weird, right? But the point is, you are all thousands, if not millions of things that make you unique, that make you who you are. Nobody in this room is the same, and there's thousands, millions of things that separate you. And it's hard to talk about that for a minute. It's hard to think about those things because it's not something we actually think about on a daily basis. Okay, well, what makes me different? What makes me unique? What can I bring to the conversation? And all too often, when we're going in to talk about science, the only hat we're wearing is our scientist hat or our graduate student hat. Instead of thinking about all the other hats that we wear, that we could use to engage someone. And also thinking about all the other hats that they're wearing. They're not just wearing their advisor hat or their scientist hat or their other graduate student hat. There are thousands of other things that make them who they are, that make them unique, that you can draw on to make a connection. And it's important to think about those because it's about a connection with your audience. And it's about engaging them and bringing in those other pieces to do that. So I want to ask, who here, when they were talking to their partner, found out they had something in common? Like what? What were some of the things? Shout them out. What was it? Share what? Okay, shared place. What else? Both misanthropes, okay. You're both what? You care about the world. What else? What were some other things? You like pizza. Good. What else? Bats? Okay, bats. An interesting one. What else? Same height. You both new to the U.S. Okay. What else? Tree lovers. Okay. What else? Interested in wildlife. Okay. Oh, users of wildlife. Okay. So tired of being in meetings. Okay. What else? Mothers and daughters. Yes.
We both want to skip some afternoon sessions.
You both want to skip some afternoon sessions and go for a hike. Okay, so these are all things that you have in common that you probably wouldn't have known if you didn't talk to someone and find out what are the things you have in common. So it's just important to think about those things. Think about those commonalities. And how did it make you feel when you found out you had something in common with the person?
Great.
Great. Yes, good. You felt like you had a connection. You paid attention more, I bet. So if you can establish that with your audience, you're going to get them involved. You're going to get them to pay attention. Whether it's, you might say, I have nothing in common with Representative Lamar Smith. But you know what? You probably do have something in common with him. Whether you both have kids, that's something in common. Whether you have been to Texas, think about the things that you have in common. It's hard, but it takes thought, and that's the thing about being effective science communicators. It takes work. It's not easy, and it takes practice. So I want to ask another question on that exercise. Who, when their partner was talking, especially for those of us who went second, maybe wandered in their mind a little bit, thought about, oh, what am I going to do this afternoon when I go hiking? Or what am I going to eat for dinner tonight? Or what am I going to say when it's my turn? Raise your hand. We all do it. We all wander. As much as you want to try and stay and pay attention, people's mind wanders. We've all been on the road, right? And not realized for a second, I don't remember driving this last 15 minutes. We've all done it. Our mind jumps, our mind wanders. What brought you back? What made you pay attention again? The rabbit in the road. The rabbit in the road. Okay. What made you pay attention in this situation?
I was interested in what they were saying.
Yes, they said something interesting. Sure. What? Unexpected. Something unexpected. I heard somebody say.
I thought you were going to quiz me.
Yes, you thought I was going to quiz you. But that's important. Having states on something, whether they're real or false. Even if I did quiz you, you knew you wouldn't get a grade. It didn't matter. But if there's an inherent, stake at the end, people pay more attention, and that's important to recognize. What else made you come back?
I think eye contact.
Eye contact. Realizing they're watching me, they're paying attention to me. Sure. And that's why body language is so important. If you have a speaker on stage that's thinking about what am I saying next, does that make you want to pay attention? No. But if there's the possibility that I might come up to you and I might look at you straight in the eye, it's going to make you pay attention more. It's going to make everybody else pay attention too, if there's actually a connection. What else made you pay attention to your partner again?
Maybe something more personal and less about their work.
Yeah, on the personal side, because you started caring about the person, right? So sharing something personal can be a great way to engage your audience. That's a huge one, and we'll talk about storytelling in a bit, and how do you bring your person into it. What else?
Well, we've just done the exercise where we were looking each other in the eye and not talking. And so it was kind of, we were looking at each other in the eye, and I was like paying more attention because we had just done that mirroring.
You were
Yeah.
conscious of paying attention, sure. And getting people conscious of paying attention and changing the way they're doing things. And your partner's body language.
She doesn't like basketball, and I like basketball.
Okay, so something that you had that was different. Yes. So it doesn't have to be things in common that make you pay attention. Things that you don't have in common often make people pay attention. And these are important things to recognize when you're communicating with someone. So think about this. Think about this exercise and how you can bring these things in next time you do a poster presentation, next time you do a presentation on your science at a conference. How can you bring some of these things in to try and connect with your audience more? Who knows what's going on here? This is just a few examples. Anthrax, yes. So what was happening? This is back in 2001. What was going on? Yeah, anthrax got sent to the White House in envelopes. Some people actually died in the Postal Service that came in contact with this. What was the American public doing while this was going on? Were they happy? Were they calm? No, they were panicking. The American public were panicking. People were taping their windows shut, even though that had nothing to do with it. So, where would they go? What agency would they go to find out more about anthrax? The CDC. Okay, so I'm going to show you what the CDC had up on a public portion of their website to talk a little bit more about what's going on with anthrax. Is this going to calm the public down? What are they going to get from this? What words? Maybe lethal and toxin and bacteria, right? And this is where knowing your audience is so important, because it's not just knowing them and thinking about the other things that they are and how they're coming to the table, but thinking about their fears, thinking about what they need to get from you. And it's not just about the message you need to give them, and this is a huge distinction. It's about what your audience needs from you. And what does your audience need from you here? Reassurance. This is what they need. And the facts. And you can layer in the facts, but you have to give them what they need first. And this is a shift. It's not just about what you want to say, it's about what they need from you. Really thinking about that. What are they coming from? What fears might they have? What values might they have? What are they scared of that you're going to take away in terms of conservation? And this happens all the time. You have to address that stuff first. And then you layer in the complexity. We're going to do another game really quickly. Yep?
I guess I have a question.
Of course.
I guess I'm a little uncomfortable with the idea that there is scientists and there is an audience. So I look at the CDC, the first CDC website, and I can see for some people, what's on the fact would not be what they want. For other people, what's on